The following video is on absolute value. So the first question we have to answer is, what does absolute value actually mean? So the algebraic definition of absolute value is if I have the absolute value of x, it turns into a function that means two different things based on what the value of x is at any particular time. So we actually call that a piecewise function, and we'll get into those a little bit later on in the year, a little bit more. But the absolute value of x is defined to be the line y equals x when x is greater than or equal to 0, and it's defined to be negative x when x is less than 0. So, for example, if I have the absolute value of 3, notice that 3 is greater than or equal to 0, so my output is 3. If I have the absolute value of negative 4, notice that's less than 0. So I take the opposite of my x value. So that's negative 4, which gives me 4. So that's the algebraic definition of what's going on. The geometric definition is what we're going to spend more time actually thinking about. So the geometric definition of absolute value is distance from a center or distance from the middle of something. So, for example, if I take a look at a problem like the absolute value of x equals 7, what I'm doing is I'm saying that the distance that x is from the center is 7. So notice that my distance could go in either direction of the center. So if the center of my graph in this problem is 0, my distance could be 7 if I move 7 to the right, or my distance would be 7 if I move 7 to the left. So in this particular problem, I would say x equals 7 or negative 7, because in either case, my distance is 7. Because distances essentially cannot be negative. So that's geometrically what's going on. Now, if I take a look at a little bit more complicated problems, what I end up with is I have a situation where, for example, I have the absolute value of x minus 5 equals 8. So if I look at, or I just substitute in values that make this work, and I can kind of think about what's going on, I know that 13 minus 5 gives me 8. So that means that the absolute value of 13 minus 5 is 8. So that means one of my answers to this problem is x equals 13. I also could figure out that negative 3 will work, because this will give me the absolute value of negative 8, which I know distance-wise would be 8, according to my definition algebraically. The absolute value of negative 8 is 8. So if I take a look at what's happening on a number line, if I graph my answers are 13 and negative 3. So I will put 13 on a number line, and I will put negative 3 on a number line. And essentially what I'm doing right now is I want to figure out what is the center. So if I take a look at the center of this, I need a distance of 8 from both sides. Something that is a distance of 8 from both sides is 5. So my center is 5. So if I take a look at what's happening, this value will basically tell me my center. If I substituted in x equals 5, that would mean I had the absolute value of 0, which means I would have 0 distance from the center. So that's essentially what's happening from a geometric perspective. Solve the equation. So we're going to spend a lot of time doing algebraic solving, and then I will plot the points and show you that geometrically it makes sense. Solve the equation. Number 1, absolute value of x plus 5 equals 12. Procedurally, what we end up doing to solve these equations is we say that x plus 5 could equal 12, or we say that x plus 5 could equal negative 12. That is because if something is 12 units away from the center, notice that my center in this problem is going to be negative 5. What I can do is draw a number line where my center is negative 5, and I know that my distance is 12. So since a distance is 12, that means I can go to the right 12, or I can go to the left 12, which ultimately is why algebraically we set up two separate equations where x plus 5 equals 12 and x plus 5 equals negative 12. So what I can end up doing is figure out that my answer would be 7 or negative 17. I can do that from a geometric perspective, or I could algebraically subtract 5 from both sides of the equation, and I end up with x equals 7 or negative 17. If I take a look at problem 2, I will do the exact same thing, but what I have to do, and this is kind of important, is you need to get the absolute value part of the equation all by itself. The math word that we often use for that is isolate. So you want to isolate the absolute value part of the equation before you break it into two parts. So get the absolute value by itself, then do the two cases that are required for absolute value from an algebraic perspective. So I'm going to add 12 to both sides. So now I have 4 times the absolute value of x minus 3 is equal to 20. Then I will divide by 4. So I get x minus 3 equals 5, or the absolute value of x minus 3 equals 5. If I then break this into two cases, I have x minus 3 equals 5, or x minus 3 equals negative 5. When I solve this, I get x equals 8 and x equals negative 2. From a geometric perspective, this makes sense because my center should be 3, and my distance from the center should be 5. So if I'm looking, the center's 3, I end up with answers at 8 and negative 2, and both of those have a distance of 5 from the center. Now let's take a look at inequalities. So inequalities basically operate the same way, except I now have to write inequality symbols. So let's break this into two cases. I have x plus 1 is greater than or equal to 7. And then I have x plus 1 is less than or equal to negative 7. Let's think about why that might be true. If my distance is greater than or equal to 7, if I'm taking a look at the number line, and I know that my center is negative 1, I want my distance to be 7, and then I need my distance to actually be more than that. So when I solve this, I get x is greater than or equal to 6, and x is less than or equal to negative 8. If I put these on a number line, I will have negative 8 and 6, And then I need my distance to be more than that. If my distance is more than that, that means my arrows are going outside. They're going further away from my center. So when I take a look at this, that's clear that x is greater than or equal to 6, and x is less than or equal to -8 makes sense in the context of the geometric definition. Absolute value of x minus 2 is less than 5. I'm going to do that because I want to isolate the absolute value or get it by itself first. Now I'll break it into two cases. X minus 2 is less than 5, and x minus 2 is greater than -5. So, from a geometric perspective again, what I want to have is I want to have a center at 2, and then my distance is 5. So, a distance away of 5 would mean that I have 7 and -3. But I have to be careful because these are less than or greater than signs. They're not inclusive of the actual value. So that means that instead of 7 being included, I need to put an open circle. And instead of -3 being included, I have to put an open circle. And then what I have is my distance is less than, so that should make sense that x has to be less than 7 and x has to be greater than -3 because my distance should cover all of the values that are between those two values, since those distances would be less than 5. I will quickly do the remaining problems. X plus 2's absolute value is greater than or equal to 8. So that means the two cases are x plus 2 is greater than or equal to 8, and x plus 2 is less than or equal to -8. So x is greater than or equal to 6, and x is less than or equal to -10. So from the perspective of the geometry, my center is at -2, and my distance away is 8 in both cases. And since my distance has to be greater than 8, that means it has to be more than 6 and less than -10. Number 6, I'm going to add 10 to both sides, divide by 8, so I have the absolute value of x minus 3 is greater than 2. So geometrically, my center is at 3. My distance is going to be greater than, so I have open circles. So I should have 5 and 1 as my answers. If I take a look at this, I have x minus 3 is greater than 2, which means x must be greater than 5. Or x is less than 1 when I have x minus 3 is less than -2. Problem 7. I'm going to subtract 4 from both sides. So I have 3 or -3 times the absolute value of x plus 5 is greater than or equal to -20. Now I'm going to divide by -3. So the absolute value of x plus 5 is less than or equal to 20/3. That's kind of an important point. Remember that when we multiply or divide by a negative, an inequality sign changes. So my center is at -5. Then my distance is 20/3. So 20/3 is about 6, or it's exactly 6 2/3. So that's something to keep in mind. So I have x plus 5 is less than or equal to 20/3, and x plus 5 is greater than or equal to -20/3. So when I subtract 5 from this one, I get x is less than or equal to 5/3. So 5/3 is over here. And then when I subtract 5 from this one, I get x is greater than or equal to -35/3. And since this distance was a less than distance, it's definitely going to be all of the values on the inside of that. Number 8, so I get the absolute value of 3x plus 6 is less than -4. I have two things that are going on here. First, I need to figure out what the center is. My center is actually not 6. My center is 2. And so what you have to do is kind of understand that in this problem, I have 3 times the absolute value of x plus 2, or I'm sorry, 3 times x plus 2. So my center, in this case, is actually -2. It is not -6. Then the other thing that I have to keep in mind is that if I have this 3 here, that is actually like I'm scaling the distance a little bit. So my distance from the center would be -4/3. So I would take whatever this is and I would divide it by the number on the inside of this. So my distance from the center would be -4/3. The third thing that we have to understand, I'm putting all the crazy things in one problem. So center doesn't look as if it appears when it begins. Distance doesn't exactly look like it does when it begins. Last thing, this actually has no solution. The reason this has no solution, my distance can never be negative. That doesn't make any sense. I cannot have a negative distance. So, since when I solve and get the absolute value isolated, I have it being less than a negative number, this doesn't make any sense. So, there's no solution. Last thing before I move to graphs, we're going to talk about how to write all of these problems and answer them in interval notation. So, problems 1 and 2, you can just write like we did. Problem 3, I'm going to write this in interval notation, and I'll write all of my interval notation solutions in green. So that would be -infinity to -8 with a bracket, and then I'm going to put a u on the inside, so that means union 6 to infinity. Anytime there's a filled in circle, it's a bracket, and anytime it's an open circle, it's a parentheses, and infinity always gets a parentheses. So problem 4, -3 to 7. Notice they were open circles. Number 5, I would have, I'm sorry, -infinity to -10. Sorry, that's a bracket. -infinity to -10. Union 6 to infinity. This problem, I have, it was going outward, correct? Oh, and I guess I forgot to do that. So this problem is going to be -infinity to 1, union 5 to infinity, and everything's in parentheses. Problem 7, I have bracket -35 thirds, 5 thirds, another bracket, and then this one is no solution. So I can put a 0 with a line through it. Number 9, absolute value graphing. So if I plot some points, it's very clear that absolute value graphs end up looking like V's. Okay, so it ends up looking kind of like a V. What we have to understand is that if I substitute 4 in for x here, 4 minus 4 gives me 0. So 2 times 0 gives me 0 for y. If I substitute 5 in for x, I get 5 minus 4, which is 1, times 2 gives me 2. If I substitute 6 in, I get 4. If I substitute 3 in for x, I get -2, but the absolute value of, or -1, but the absolute value of -1 is 1. And when I multiply it by 2, I get 2. And so this is what it kind of looks like. So my graph, notice, gets a little narrower. And the narrower comes from the fact that everything gets multiplied by 2, so my slope kind of changes. And then notice that it got moved to the right 4 from our normal graph. That's because there was a shift. If I substitute 4 in, that actually gives me 0 coming out. So that's the shift that's occurring. We'll talk a lot more about that within the next few days. So in this problem, if I substitute some points in, I end up with substituting in 0, I get 3. If I substitute in 1, I get 2.5 or 5 halves. If I substitute in 2, I get 2, and likewise. on the other side. So 0, 3, 2, 2. So this one gets wider than a normal graph. The wider comes from the fact that 1/2 is going to make the slope a little bit less steep. The negative makes it go down instead of up. And the +3 actually moves my graph up 3. So if I want to check out problem 12, what I'm going to guess if I substitute things in is this +5 is going to move my graph up 5. This -3 means that it's going to open down, and it's going to be steep because the 3 is going to change my slope by multiplying it by 3. And then this value is going to move my graph left 1. Because if you notice, when I had a problem like this, the -4 moved my graph to the right 4. So if I'm guessing, all of this stuff will be true. So left 1, up 5, opens down, so the V is going to open down, and my slope, so to speak, is kind of like 3. So that would be my guess for what the answer is if I plugged in points, and um, that's actually what it is. But I'm not going to go into that with too much more detail because we will do that for another few lessons.